Today we'll be talking about lobby system, including online status system which will display whether a friend is online or offline in the friend list, latency based on lobby which will place players in a different region or location based on his latency, invitation system so that a player can invite his friends to the lobby. We use a mind map which is similar to this one to explain how to design an MMO system. We can actually use it to design all kind of system. For example, the friend system we have designed is using a database for persist data and a GraphQL API to send and receive data. Today, let's see how do we determine which method to use by using a simple and easy to use strategy with 3 examples. And we will provide the AWS CloudFormation template to set up all the systems in field clicks in the example project as usual. First, let's take online status system as example. An online status system is used to display an online or offline status in player's friend list. This doesn't need to be synced in real time and multiple times. We can just query it in constant time period. So we just need a GraphQL or restful web API. Due to variations in daily schedules, the number of online players fluctuates significantly throughout the day. The number of the friends of each player has is also uncertain. Therefore, we cannot accurately determine the access frequency of this data, so we use web application. And online offline status is a temporary data which will be changed when player enter or leave the game. So we use in-app memory of the web application. We use a similar way to design an MMO system with a Python and a fast API. So we can just add this system in it. Next, let's talk about the lobby system. A lobby system is used to team up with friends and interact with other players or environment object. For example, take a pose, draw a doodle, kick cans, or anything else. It has synced many things, for example, environment object transformation in real time and multiple times. So we can use Unreal dedicated server, but this data is not real data. We don't need any database. As we mentioned in the previous video, when we are working with Unreal dedicated server, in order to reduce the performance cost, we can create a simple collision map. For example, in this tutorial, we will use a queue blocking volumes to cover benches and the plan pods and use level streaming to stream benches and the plan pod mods into client sites. We can also only create online lobby for players who wants to play with friends and only use offline lobby if the player doesn't want to play with any friend to save cost. Lastly, let's talk about the invitation system. Player can send invitation to his friend and ask them to join on its own lobby. So the invitation should be sent in the real time and it won't make sense if the player goes off. And the player should only need to send invitation at a low frequency. Because it is not a received, the invitation loses its meaning. It doesn't indicate any real-time data. We don't need any database. We can see it is very easy to use strategy to determine which role we should take. It is good to use at a starter level. To connect the online status system, we call send restful request every fixed time interval using a looping timer. In order to place the lobby in the region or location within the lowest latency, we first need to obtain the latency of the client to all regions. Since sending the ping request is free, we can use the timer with a fixed time cycle to ensure that we always have the latest latency data available without having to wait for ping responses when needed. Then we use the latency data to call the start game session placement node. The game session placement is a request that takes longer time to execute. And the AWS generally use RESTful web APIs. In RESTful Web API, for longer running requests, the request and the execution are separated. After sending the start game session placement request, we need to use the describe game session placement node to query the execution process of the game session placement. Once the game session placement is fulfilled, we can obtain the game session ID, player session ID, as well as the IP and the port correspondingly to the game session. To connect the invitation system is similar with the friend system. We call send GraphQL request to send the invitation. We provide access token and AWS AppSync will verify it as the same as a friend system. To receive an invitation, we create a subclass of the subscription handler and construct it. Call subscription GraphQL subscription and connect then send the star GraphQL subscription request. Once the invitation is received, received data message in the subscription handler will be triggered. To accept the invitation, we call description game session to make sure that invitation is still valid, and then create a player session with the game session ID in the invitation. To convert a WebSocket MMO system we designed in the last video, we can set tick interval BP first person character to 0 and the position update interval and in CloudFormation stack to 0. In order to upload our project to the AWS, we will need to compile our project as Linux server executable. We will show it both in Mac and Windows. For Mac, you will need to go to the project folder and type those commands in the terminal, like bash dot slash initiate build linux.sh, and we will just wait till it finished. And in Windows, the step is pretty straightforward and easy. So you just go to the editor and go to platforms Linux ARM64, pick development and the server and package the project, and that's it. After compiling the Linux ARM64 server, we compress the compiled files along with the file required by the server into the zip file. And then upload it to the S3 bucket we created in the first video. We can create AWS CloudFormation stack while we are uploading it using the AWS CloudFormation template we provided with the example project. We can set a position update interval here to convert a WebSocket MMO system to the real time. You can change other parameter based on your use cases. After after the uploading finished, we get object version from S3 bucket and place it into the game server build object version in the AWS CloudFormation stack. Let's continue after it finishes. After the AWS CloudFormation stack is finished creating, we can set the necessary variables in the game instance based on the CloudFormation stack output. We have added the quick link to the AWS Cognito user pool client so that we could get client secret easier. Let's check the result. I have created two accounts off screen. The player WebSocket MMO is blue. We can see the WebSocket MMO is real time now. I have added them as a friend to each other off screen. The online offline status indicator will be updated every 30 seconds. So it might showing that test user 2 is offline and test user 1 client because test user 1 log in first. Let's change to online now. On the test user 2 client, test user 1 status is online. The player will join offline lobby by default. We can press left shift key to switch to play with the friend to enter an online lobby. It uses game session placement, so it will take longer time to join the lobby. Once test user 1 enters an online lobby, the test user 1 can invite his friends to our game. Test user 2 will pop up a notification when his client receives an invitation. Once the test user 2 decided to accept the invitation, it will try to bring the test user 2 to the test user 1's lobby. We can see that the two clients is joined together and seeing each other's silver person mesh. That's all, and thank you guys for watching.